What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Hello everyone, welcome to Charlotte IoT. My name is Dan Thayer and I'm president of Charlotte IoT. And this is just like an awesome group. We normally meet the first Tuesday of the month, but because of fireworks and vacations and everything, we pushed this one to the second Tuesday. And I think it hurt our attendance a little bit, but normally the first Tuesday of the month, we're here and we always have really good content in our meetings. And we do lots of hands-on stuff like tonight, and we also do technical presentations, and we do lunch and learns during the week. A lot of the lunch and learns are more business focused, but not necessarily. But just follow us on Meetup and come to as many of the meetings as you can, because they're like amazing. And the reason this group rocks is we have an active board. Raise your hand or stand up if you're on the board. Rob, Glenn, Graham. So these people are like amazing, and it takes a lot to run a group like this. We've been doing it for 5 years. And there's no way I could do it, and you guys wouldn't want me to, because these guys are like 10 times better than anything I could do, and just really awesome. We've got a website that's about to come, and Glenn, there's a countdown on the site, so with a deadline, that means it's going to happen. I'm excited about that. And we had one previously, but we lost control of the domain, so now we're going to have control of it again. And Glenn just does really awesome work, and so I'm really stoked that he's doing that. He's our social committee, and really more than social, he's just amazing. And tonight on Facebook and Instagram, if you say nice things, then Glenn has tickets to the Knights game on Thursday. And it's Thirsty Thursday, Knights, fun, baseball. But you have to say something nice, and we'll do a raffle at the end for the people who say like the nicest things. And we might weed you out if you're not as nice as some of the others.
Yep, so I just want to know, I haven't posted the picture yet. I will in a few minutes. We want likes and comments on that picture. Instagram or Facebook, we're easy to find.
Yeah, beautiful. And then YouTube, Joseph, he's been awesome doing the YouTube. We stream live, and we've been streaming to another group who, they don't do all the meetings, but most of the meetings up in Lake Norman. And they're really great. And Joseph has a company that you can get him to make videos and productions. And is there anything more you want to say about?
Well, I'm going and starting to teach small business, teaching video production to small businesses to help them get their YouTube presence.
It's amazing. And tonight, if there's something you want to learn more about, like if Rob's going to like explain everything really well, but sometimes you just want to see it again, you can go to the YouTube and watch it again, and it's just great. We've got Slack and Twitter as well, but tonight we're only giving away prizes for Instagram and Facebook. And our sponsors tonight. So Dave Kaplan, can you please come down here? Tell us a little bit about the Intersect group. And not only did they like pay for dinner, but look at that table of swag. It's like really amazing stuff. We're really appreciative of it.
Thanks for having me. The Intersect group is a full-service IT staffing firm. We do contract to hire, direct hire placements. We've been around in Charlotte market for about 6 years. I'm fairly new to the Intersect group, honestly. Been there for about 6 months, but previously was at another IT staffing firm here in Charlotte for about 10 years. Glenn and I were talking earlier about like a differentiator. I think for us, we were talking earlier, I was talking with some people earlier, is we're big on connections with people and do it right by people, both from our client and from a candidate perspective, which is really important to me personally because I've been on both sides of that relationship. You know, and I think if you guys have any questions about our company, you know, as a testimonial, you could probably ask Glenn about, because we've partnered together for probably the last 8 years, 9 years.
At least.
So yeah, but if you guys have any questions, me and my team are here in the back. We'd love to talk to you a little bit more, and I appreciate you having us. Look forward to learning something.
Yeah, thank you, David.
Thank you, appreciate it.
So my company, Pratt Miller, we're also a sponsor. We created the group, and Snap AV hosting this awesome venue here. And Graham, you want to say how awesome?
How many first timers? Good. So welcome. I always forget this, but the bathrooms are all the way down the hall at the end by the elevators. If you guys know. But I have the privilege of working here at Snap. Oops, sorry. And I get to run this awesome team called Oversee, which is our IoT cloud platform. And actually, I'm wearing the shirt because tomorrow is 5 years since we launched the platform. Tomorrow's our anniversary. So we're now sitting on 4 million or so devices connected to our platform, and are very much invested in the IoT space with our products, which are audio-video products. And so this kind of gives an outline of our cloud and kind of where our products are. I think that you have still this next slide on there that shows the numbers. So yeah, these are some older numbers. We have roughly around 4 million devices now in about 250,000 locations. So it's been a fun ride to be a part of, and work with Dan at hosting this group has been fun. So welcome.
Awesome. Yeah, and I love it when he always talks about the numbers, because it's always more than 100,000 devices like new each month, and he doesn't even mention it anymore, because when you get in the millions, you lose track. So a little bit about my company, Pratt Miller. You may have heard of Logical Advantage. I co-founded the company 16 years ago, and last summertime frame, Pratt Miller, we acquired us, and now we're doing bigger IoT projects, and we're doing things around automotive and Department of Defense. And we've always done IoT around manufacturing. And we've got this really cool Jumpstart kit. And our Jumpstart kit does things like sensor simulation, where we had a problem with one of our solutions that we were having like mesh problems. And if we didn't have simulators to simulate all the sensors, we would never have known that we had issues with the mesh before we deployed out into production. And so it gives us ways to test our solutions before we go to deploy, and it's really good. And we're doing a lot with OpenThread, and all of our solutions have over-the-air updates, so we can push down updates, and it makes a huge springboard to start projects. And our Jumpstart kit looks like this today, but we're putting in a smaller footprint on a PCB, and we'll have that ready before too long. And it works on a lot of different projects. We've got inputs and outputs for it. And one thing I think is really cool is there's a company here from Raleigh. What's your name of your company?
FazeDoc.
FazeDoc. And hold your product up for a second.
This is what we do. And I was just thinking as you were showing your products, like, man, we should have.
Yeah, I was thinking like our early prototypes would fit really good on your FazeDoc, where you can move things around. And we have tables of these everywhere with simulators going, but it'd be really nice if we had them on a solution like that to move them around. So it's pretty neat. It's a neat product you guys have. We are always hiring, and if you're a developer, please come talk to me. Actually, I take it back. Talk to David, because he paid for dinner. Really good. Yeah, talk to him. And our next meeting is going to be really big. It's at Livingston and Haven, and it's on Bosch IoT Suite. And if you guys haven't heard of Bosch, they're one of the big players in IoT. And we're going to have a 4-part meeting, and there are going to be some important people, like the head of Bosch Rexroth IoT is going to do a presentation, Rodney Rusk. And you won't want to miss it. It's going to be like famous people, big meeting, and it's going to be at Livingston and Haven's Innovation Center. And Bosch is renting tables and chairs so that we can hold it there instead of an auditorium, because we thought it would be cooler to be out in the open and look at all the innovative things going on at Livingston and Haven and Bosch. So please come to that meeting. You won't want to miss it. And we do lightning talks a couple times a year. And we're going to do it again in September, October timeframe. And sorry, I'm getting a phone call. I knew that was going to happen. That was the call I needed. So our lightning talks, we do like 20-minute talks, and they're beautiful because we'll learn a little bit, and if you're bored on a subject, we'll jump to another topic in 20 minutes, and you can learn something else, and there's always something for somebody. And it's also, if you're a new speaker or you have some idea that you want to talk about, please come talk to me, and we'll add you to the agenda. And even if if you don't want to do it for 20 minutes, we can do it for 5 minutes. It's a great way to get into speaking and to share what you know with everybody. And tonight, the main event is Rob. Rob Schoon. I can't pronounce your real last name, but we call him Schoon for short. How do you pronounce your?
Van Schoonerveld.
I'm sorry, Van Schoonerveld. But Rob's been amazing from the beginning of Charlotte IoT. He's done, I can't even count how many hands-on labs, and he does all kinds of activities that are STEM-based, and really big at helping us at all the maker fairs, and just really been a huge contributor to the board of Charlotte IoT, and really stoked to learn about the Connect tonight. So thank you, Rob, for presenting. Yep.
We're going to give it a try live.
All right, well, before we get too live here, this is going to be a little bit more fun if we have some more people in the front row. If anybody wants to volunteer so that they can be on the camera, come down and fill up some of these seats. Otherwise, we're probably just going to have these two gentlemen here in our camera view. So. What's that? It is now. All right, we got some good suckers volunteers here. All right, so this, give me a couple seconds while I get switched over. So this was initially going to start out as a lightning talk, and then I don't see him here tonight, but I was challenged at our last meeting here saying, hey, we haven't had a hands-on lab in a little bit, and so this kind of turned in from being a little mini lightning talk. I don't know if it was officially announced last month, but I knew that this was going to be coming out here between our last meeting and this meeting, so we kind of talked about how can we maybe integrate this a little bit, the Azure Connect, with actually talking about some of the Microsoft Cognitive Services facial recognition APIs. For those that were here at our meeting last month, was anyone here last month? All right, so what y'all need to do before we get started here is go up on YouTube, watch last month's meeting so you know a little bit what I'm talking about here. But we actually had some, Jeremy, who's also on our board, was talking about some new devices, and we were talking a little bit about IoT Edge and what those devices might be able to do in terms of AI and hooking into all of the new hotness that is the AI ecosystem. And so where these devices actually fall in is right there. We have a combination of devices that will actually run on the edge as well as devices that will run up in the cloud, and that's going to be a little bit about what we're going to be showing on tonight. So who am I? I work at Microsoft currently. I get to work on a really, really cool product called the HoloLens. Has anyone heard of that? A couple people. So I actually help developers build solutions for the HoloLens, and soon hopefully here to be the HoloLens 2. We also work with folks that are going to be working on this Azure Connect device. In my spare time, I actually run a bunch of STEM programs for local schools, Union County, CMS, and stuff like that. We have groups as large as 100 come out to the Microsoft campus to participate in events. I heard someone before the meeting talking about the Circuit Playground Express. That's one of our go-to devices that we use a lot for teaching kids that are interested in getting into these STEM-based projects. Dan mentioned that we have done a lot of stuff at the mini maker fairs here in Charlotte at Discovery Place. No more mini maker fairs? Maybe no more mini maker fairs?
So Make Magazine laid off the 22 employees, but hopefully Discovery Place is still going to have a maker fair this year. They're still working it out. But I told them if they would, Charlotte IoT would be a big cornerstone of it. Yeah, definitely. It's definitely, we've had a lot of good traffic, a lot of good visibility at those events with folks coming through just trying to learn about what the IoT thing is, what the maker movement's all about.
And so this group here, and like this is a group that I've been part of since it was Logical Advantage, since one of our first meetings was in their boardroom and we set their table on fire with automated robot or whatever. So it's been this group has been a really, really fun group, and for the first timers I saw a bunch of hands come up. I highly encourage you to kind of keep coming back, because there's always something really interesting month in and month out. This isn't going to be a lightning talk. It's going to be a little bit longer than that, so hopefully none of you will get bored after 20 minutes, because we don't really have any other content tonight. The things that we are going to talk about is just the device evolution. So how many people remember the original Xbox 360 Kinect? How many gamers in this room? So this was a device that first came out 2010, I think it was, is when the Xbox 360 released. Very, very basic. It's kind of like the birth of sensors here. You know, had a simple RGB camera, very, very low resolution, had a very, very basic depth sensor, and it had a microphone. But you know, it was kind of the birth of how can we actually have devices that can do detection and interaction with people. Following that, for the first year and a half or so, yeah, it was great that this device was connected to an Xbox, but you know, makers being makers and hackers being hackers, they went ahead and they took the device, they took it apart, they tried hooking it up to their own pieces of hardware. I think one of the first devices that I ever saw the original Xbox Kinect on was a Roomba, and somebody had basically made a Kinect on a Roomba that would somehow not run over people or something. I don't know. I don't remember all the details of it, but it was basically, here we had a closed platform, and folks were able to go ahead, take the device, and open it up. And so eventually, I guess we kind of got the hint a little bit and went ahead and actually released a formal SDK for the Kinect, and it was released initially as Kinect for Windows. Essentially the same device, but it did have a little bit of changes in it just because of the connectivity to the Xbox was different than connecting to a PC. But it was something cool, and I know Dan has about 5 different Kinect projects that he's built over the years. Mainly their purpose is to scare kids at Halloween, but the idea being that you could actually take the device, you could detect people coming up, and I think you were actually doing some of the skeletal tracking and body tracking, and basically skinning kids that would kind of come up and putting them in different costumes and having them move around on a projected wall, if I recall correctly. So a lot of really, really cool stuff that you could come over here. Next along line, Xbox One, released in 2013, much higher fidelity camera, a lot better depth sensor, and it was generally seen as a complete failure in the marketplace. You know, nobody wanted to pay for an Xbox that cost more than a PlayStation 4. You know, the Kinect was basically seen as kind of gimmicky. You know, there weren't a lot of cool games being built for it. And a lot of folks actually thought that maybe this was kind of the death of the technology. I know there was a bunch of really, really cool things happening with it, but no one was really using it for the original intended purpose. So, you know, they did actually go ahead and create a Kinect for Windows version 2. It was based, again, on the same one for the Xbox One. And again, you know, you had a lot of makers, hackers, a lot of researchers, colleges, and stuff like that were trying to figure out what cool things could they do with the sensors that were actually put into the device itself. And with that being said, one of the devices that actually followed this, and I don't know why I don't have it in my picture list here, was the HoloLens. So a lot of the learnings that actually came about from the Kinect and having a static-based, you know, I'm actually going to kick myself now for not actually bringing the HoloLens with me. I don't know why I didn't, but come in one of these future months and I'll have one for you and y'all can play with it. But with that being said, you know, a lot of the technology that went into these original Kinects was moved onto the device, HoloLens being the first fully untethered, wearable, augmented reality device. So from there, again, a lot of people thought that the technology was going to end, moving over to the HoloLens, and then kind of in a little bit of a surprise announcement, Microsoft actually announced the Azure Kinect, I believe it was last year at Build, but this device actually started shipping out to retail channels last week. I think I got a message on the 4th of July from Dan saying that his has been delivered. Yes. But the really, really cool thing about this is they've actually updated and upgraded almost everything on this.
So, what are we actually looking at? This device was actually fully designed for folks to kind of play around with, folks to kind of make stuff with, and we've gone ahead and released all of the a lot of detailed specs so people can actually do whatever they want with this device. There's full CAD drawings for it, so if you want to take it apart, integrate it into your own solution. But what you'll notice is we actually have a much better depth sensor. It's got, if you see here, and I'll show it a little bit more in the next picture, but that's what number 1 is. So that it can do both narrow field and wide field ranging. It's got a 7-mic array. We're not going to be talking about it tonight, but there's the vision aspect of AI, but there's actually a lot of really cool stuff that you can do in terms of speech recognition from a cognitive services standpoint. And I think we talked about it at some point. I don't know if people are familiar with like Lewis or natural language processing, but a lot of the technology that goes into speech recognition on devices like this is also get used for your digital assistants. We had a presentation from who did the Siri presentation and the Alexa presentations that kind of talk about how does voice processing, voice recognition, and voice natural language processing actually work, which was, I hope we have that one recorded too, because that was a fun one you guys should go back and watch at some point if you're interested in it. Updated the camera to it. We give you access to the inertial measurement stuff, the accelerometer and gyroscope. And the real cool thing that we actually saw, a lot of people would use multiple devices together, but there's no way to sync across them. So one Kinect could be taking a picture, emitting its IR field. Another one would kind of go ahead and do that, and they would actually interfere with each other. So the devices now actually allow you to chain multiple, I think it's up to 32 devices together, and so that they will actually time when they fire and time when they take the picture, so everything's in sync and you don't have them actually adversely interacting with each other. So we talked a little bit about this. This is the actual time of flight depth camera. This is the same technology that's going to be built into the HoloLens 2 that's going to be coming out here shortly as well. So, if you're thinking about, hey, I've got a multi-$1,000 headset that I'm wearing to do a whole bunch of cool stuff, if you're interested in the technology and what you can actually do with depth sensing and stuff like that, you can actually get it in this one too. It's the same sensor kit. So that's how we actually go ahead and do that. We actually, I mentioned before, it will actually, that's what I want to show. It'll actually go ahead and actually give you back two different images. So the one on the left is actually your depth imaging field. So you can go through and determine what's near, what's far. Nice color map for that. And then the other image that it will give you is actually the raw IR image data. So if you want to do something just with, if you want to do something with just that image, or if you want to do something with the emitted one, you can do that as well. It also supports a passive IR mode, so instead of actually emitting to actually light up the room, you can actually just get whatever the natural light is. Yeah.
With the color sensor or the color depth sensor.
Yep.
Does it give you like a scale, like red is?
Yeah, so you can. It won't give you a scale there, but you can actually get the points specifically from the depth sensor. I believe, depending on if you use narrow field or wide field, it can actually be millimeter accuracy. So you can go ahead and actually figure out how far away various things are, and you can build your scale based on that. And so then the other two things we basically have a narrow field view, narrow field of view and a wide field of view. That the two different camera modes that are supported. It all basically depends on, do you care more about how much depth you can measure or how much width you can measure. So depending on what your specific application is, you can actually go through and set the camera into one of those modes. We support binning. Does people know what image binning is? So what image binning is we support something called 2x2 binning, which will actually take a grid of 4 pixels and combine them into one kind of like a megapixel. It can be good for generalizing images and stuff like that. You lose obviously a little bit of the detail and granularity, but it can actually make the camera run a little bit faster if you're basically, I don't want to say throwing out data, but basically consolidating data. Because if you think about it, things that are right next to each other are probably going to have the same spatial distances and stuff like that as well. We talked a little bit about IMU data. It does actually have the 3-axis accelerometer and gyroscope in it. The cool thing there is so that if you're, depending on your application and how you're actually using it, you can actually determine how this device is being used and moved throughout space. So if you tilt it, if you move it, if it falls, that type of thing, you'll be able to actually get that information from it. And one of the biggest changes that we've actually gotten and added is joint tracking. So, and Dan, you might be able to remember this a little bit better than I can off the top of my head, how many joints we actually tracked on the previous devices?
Oh, God. I think it might have been 26.
Okay. So we are still actually tracking those same 26 points, and you can kind of see where those are all defined here on the body itself. Everything's based on your pelvis and where we think your pelvis actually is. The cool thing is that all of those joints are actually have like a parent-child relationship to the pelvis. So if you want to go ahead and know what the pelvis is connected to, you know, kind of that old song, you know, the hip bone's connected to the, yeah, all that good stuff. Yeah, I'm not a singer, we're not recording this, right, Joseph? But it'll go ahead and actually track those, and you'll actually see, you know, you actually can get a map of just the moving skeletal joints within the within your image frame itself. I want to say for the previous ones, and it changed over the course of the various devices, how many actual skeletons and stuff like that we were able to track in an image. But with the new one, we're basically, with the Azure Connect here, we're basically limited by the horsepower of the computer that's attached to. So I've seen as many as 13, 14 people in an image and all getting tracked within there. Is that a normal case scenario? Possibly not, but you know, the ability to have that there is something that's actually pretty cool. In addition to individual joint tracking, we can actually do body index mapping. So when a person is actually in scene itself, the camera can actually assign almost like an overlay of where that person is. So instead of actually tracking joints, you can actually just track individual people throughout a scene and determine, you know, how they're moving, how they're interacting with people, and the color that they can be lit up in can be associated with their actual depth and position relative to the camera itself. So if you want to know, you know, who's in the background, who's in the foreground, and stuff like that, we can actually do that with the body indexing. All right, so probably don't want to hear me talk about this as much as you maybe want to see me show it off here. So let me go ahead and do that. Oop. All right. This is where we're going to want some folks here in the front row. So right now I only do have one device connected, but if we do actually have multiple devices connected, each of their serial numbers will be listed here, so you can actually show and preview different devices. But we'll go ahead and open that up.
Can you load that up?
Nope. I cannot. What do you need help seeing?
That's fine.
Can folks in the back row see?
There's letters on there.
That was gonna be my excuse to tell you all to move forward if you can't see it, right? So it'll go ahead and do it. All of our various menu options and stuff like that are on the left. But here's where we could actually set, you know, our narrow field of view or our wide field of view. But let's just go ahead and start the camera just to show what it's actually displaying. And you can see here that, you know, we have a few folks sitting in the front row. Go ahead, wave. And if you guys were to actually, someone were to go in the back, you would actually see their change and all that stuff as well. So we can actually pick up in the back row. If you wave there, you know, you're still being picked up in the back. You can see you're obviously a little bit smaller here too, but you'll notice that we don't actually have a very big IR footprint. Do I have passive IR? No. We don't actually have a very big IR footprint in this room, so the emitter's kind of losing a little bit of that, but it's still able to very well pick up, you know, the general depth of folks in this room here. 4K video coming through our standard RGB camera. And then what you'll notice over here is we have all of our accelerometer and IMU data. And then last but not least, you can actually see what each of the various 7 microphones are picking up. So you can see as I snap there, the waveforms will actually indicate what each of the various microphones is actually picking up and processing. So it's a lot of really, really cool data. Now, to show you what the difference is between a live view on narrow view with wide view. One of the things you'll notice is that we've gone from 30 frames per second down to 15 frames per second just to process all the data.
Rob, is it possible to turn off the lights that are shining on the screen?
Is Graham here?
I'll try. Alarm starts going. Oh, yeah. First
Is
try.
that better? Nailed it. All right. So you can see here, now we're in a wide field of view, so our folks in the back row, we're not picking you up as much, but our front row is definitely a lot wider here because you were kind of cut off on the previous one here. So again, it depends on what your ultimate goal is to actually, more so what your scenario is, what you're going to be trying to do with it in terms of what modes and stuff you want to do. I don't know if you're going to be able to see anything in the passive IR mode, because I think it's probably too dark in here, but we can just show you that as well real quick. And this would just show you what the camera can actually see from an IR perspective without actually emitting anything from it. So you see it picks it up a little bit more there on the left. That's just a raw, non-emitted IR image coming off of the camera.
Now, did you augment that with IR LEDs?
You probably could, but I don't know if it would actually be beneficial based on, especially if you're trying to tie multiple cameras together, just because it's got its own timing set up pretty specifically in order to not only capture the images, but basically do its time of flight calculations. It's basically seeing how long it takes for the laser diode to hit you and come back. So it would.
Oh no, I'm just talking about the IR.
Oh, if you're doing passive IR, yeah, you could probably in passive IR mode. Yeah. No, if you're doing passive IR, I think you could, augment it with whatever you wanted. But if you're counting on that to do like the depth camera, it would probably screw it up a little bit.
I just want just the visual IR.
Yep. So, any questions about any of the stuff you're seeing in the demo here?
So you mentioned earlier, like you guys made the product so it could be used as like a hobbyist could use it and take it apart. Like, give me an example of what they would use it for.
So one of the case studies that they're actually, I believe, using this one for is to do fall detection and fall prevention in hospitals.
Okay.
So I forget the name of the company. I don't want to specify because I don't 100% know. But it's basically in kind of like nursing homes. They can use the skeletal tracking and the body tracking to determine whether or not they think somebody is going to fall. And falls in nursing homes cause a large percentage of death, essentially, in nursing homes are preceded by a fall, right? And so, yep. And so what they're able to do is basically, have these mounted in a room, and then detect if someone's standing up. It looks if they're unsteady or something like that, and potentially, hey, sit down. Someone will be right there. They can call whoever's working like a nurse's station or something like that to get out to them sooner. This device, as it is considered a developer kit, there are going to be a lot more environmentally friendly requirements than say, like if you look at the differences between say HoloLens 1 and HoloLens 2, some of those requirements have been relaxed, but for this, there's a very, I don't want to say narrow, but there is like a temperature range that this device is supported to work in. Hopefully if this is something that takes off and people are really interested in, that as it gets down the line, that'll be developed a little bit more as well.
To get to the data and the API, you have to do action.
No, not for this. And so that is actually a great lead-in for my next thing. So why am I showing off this camera in an IoT meeting, right? So the cool thing about this is that this can kind of act both as an edge device or a cloud device. And that's actually going to be kind of what we're showing off here a little bit in the facial recognition APIs. So Microsoft did announce a partnership with Qualcomm, I believe, who is actually going to be creating like a Vision AI camera where that actually does have, so this doesn't have any onboard processing, right? All the processing is happening from the computer here. For what they're kind of looking at for the other camera, will actually have onboard processing, so you can actually upload your machine learning models and stuff like that, and do like true full-on edge processing on the device itself versus on the connected device. But this could still actually do, and I don't have it up and working yet, unfortunately, but I'm actually working on a project right now that does edge-based facial detection without having to use Azure. No, we actually have the SDK that's been released for this is both Windows and Linux. So Raspberry Pi, hopefully soon. So I know that there are folks that are working on that, trying to get it up and working, but we're not 100% there yet. But yeah, I mean, it's got a full Linux SDK, so if you want to build some Linux-based device for it, you're more than welcome to do it. Any other questions on the Kinect? Okay. Cool. So Dan, I don't know if you. I mean, hopefully, what I'd like to say is if you played with the old one or even gamed with the old one and then taking a look at what this one could do, I mean, there's really a world of difference. It's a lot of cool stuff.
How much? Yeah, the dollar.
$3.99. So $3.99. You can get it shipped tomorrow.
That's into my CNC.
All right.
Is it still a thing in Xbox world? Are there game companies still developing?
So I mean it's not shipped with the Xboxes anymore. So the incentive, I would say, for game companies to make for it is limited. Like this, and this one isn't even really designed to work with an Xbox at this point. So I would say no, but you know, wind changes tomorrow. So
Some of those games were fun. I remember a few years back.
yeah. I mean, you know, wear out some dance, you know.
Yeah, right.
All right. So this brings me to the facial API. So you know, there's a lot of pretty neat applications, and I don't see a lot of laptops here, but what we'll do is we'll kind of go through the working application. Dan went ahead and uploaded the code sample to the meetup invite, so if you want to download it at some other point in time, you're welcome to play around with it. If you have questions, feel free to contact me, but what we'll do is we'll walk through the working sample just to show what it would take to actually get a face API detection application up and running. I'll have it running here. It's kind of a fun little game that we've made out of it, so if you guys want to come down and play with it and see if you can make it crash, that'd be cool too. So what is it? So the first thing that it will actually do is it'll actually take a still image and look for faces in the image itself. And so on our back end, there's a whole bunch of machine learning models that went into play to come up, what does a face look like? And you know, if you start actually thinking about what does a face look like, and you look around this room here, you'll see that everybody has pretty much a different face. I know that even twins, you know, have some different faces, and there was actually an interesting article today about the FBI talking about how different makeup and stuff like that can actually defeat facial recognition systems and stuff like that, especially when dealing with concerts. So if you're a Insane Clown Posse fan, you might know what you can do to your face to bypass some facial detection stuff. But with that being said, what we use is this is to basically detect, recognize, and analyze human faces. So, you know, the first thing detected, okay, where is the face itself? The second thing, you know, is that a face or is that something else? And we actually have a larger set of APIs than just face. It's called computer vision. So you can actually take a picture, say, of a room, and what it will actually be able to do is say, hey, this is a desk, this is a podium, I don't know if podium, but maybe podium, this is a chair, and basically it's been seeded with a whole bunch of model data to try and determine what the stuff in the room actually is. The face APIs is a subset of that, to basically say, hey, of all the things in the world, all I care about is looking for faces. And then the last thing that it actually tries to do is analyze the faces and say, okay, what attributes exist? You know, the one on the right here, you know, we think he's 32. I'll put myself on the spot here and see how good it is when I go through it. Sometimes it's better than others. But, you know, does the person have facial hair? Is the person wearing glasses? Is the person bald? What color hair do they have? Are they smiling? Are they angry? And we'll kind of go through all that and how that gets set up as we go ahead and call the APIs. The other thing that I can do is verification, right? You know, we can actually take two different faces and compare them and try to come up with a probability as to whether or not that is the same person. So that could be good. You know, everybody's worried about Big Brother, but, you know, that could be good in scenarios where, you know, you're trying to look maybe for a lost person or something like that to see, hey, do I think this person is this person? And it uses some of that same technology to go ahead and do that. So how do I build a Face API app? So for those of you that have downloaded the sample, it's pretty much already been done for you. The only thing that we're going to have that you would need to do to get that up and working is get your own Azure API key. But we're going to walk through the steps here. But first and foremost, you can go up to Azure, create a free cognitive services endpoint. And what that will do is that will actually allow you to call the API from your application. These are just pretty much simple REST APIs. So even if you don't want to use something like the NuGet package that kind of wraps all that stuff up for you, if you want to just do direct HTTP calls or HTTPS calls, you can go ahead and do that as well. We've already created a new project. We actually do have a handful of NuGet packages in various flavors, .NET Core, .NET Standard, UWP support, as well as, you know, various other languages as well. So you can go ahead and take advantage of what we already have. We're going to go ahead and create an authorized API client. So this will actually, you know, insert the keys into the application to say, hey, I'm authorized to make these calls. We're going to show you what it's going to be like to actually specify what you want the API to return. So just because you send an image out to the service doesn't mean all of the data that you could potentially want gets returned. It only returns the data you ask for. We're going to talk about describing the faces. That's kind of the beard, the glasses, the smiling, all that stuff. And then we're going to draw some rectangles around the faces just to show you what it actually recognized here. All right, so do you still see me here? All right. Okay, so the first thing we're going to do is we're actually in the portal itself. And we can actually go ahead and, how many people have an Azure account, used Azure before? This is the first time they've ever seen Azure in their life. First time they've ever seen any sort of cloud service before? Okay. And generally familiar with cloud services and stuff like that? Okay, cool. So this is the Azure Cloud Portal where we can actually go ahead and create things. Can you see this all right back there, or do I need to? Is that a little bit better? All right. So if we go ahead and create a new resource, did I lose my internet connection? Just do a search for the Face API. It'll go ahead and let me actually create this. All of the documentation and stuff like that is there. The big thing that you want to actually pay attention to is the location. So the location that you specify, this is the cloud region where the actual service that you're utilizing is going to be hosted. You just want to pay attention to it. So if you specify East US, you're going to need to know that information later on when you actually build your application. And then the pricing tier, and there's two different types of ones. I've already created and already utilized my free one for my subscription. That's the one that we're going to do. I believe it allows up to 30 calls per minute and 30,000 calls per month. So at the free level, I mean, it's designed specifically more for, you know, testing, building small applications. And when you actually get ready to actually deploy into production, you could use something more like one of the basic paid tiers or whatever. So if you come over here and look, So I'll go ahead to the one that I've actually gone ahead and created. So this is my face endpoint. And the big thing that you're going to want to look at here is this is actually going to go ahead and create your keys. So you'll see here that, of my quota, I've only used about 80 or so. And the one thing that I want to kind of call out a little bit here is that even though that endpoint specifies where you think you're going to be connecting to, that is not what the application actually uses. So it's kind of something that's a little bit confusing, but why it's more important to pay attention to the region that you actually created your actual service in. But we're going to actually go ahead and look at keys. And Joseph, this is where you're going to have to remind me to reset my keys so the whole world doesn't have them. But that is basically the access key that you go ahead and pop into your application there so that you can actually call the service or whatever. So once we go ahead and create that, the next thing that we're going to actually be looking at here is our project itself. You guys see that all right? You need a little bigger. Good. All right. Okay. So we're not going to get into app design or XAML design too much here, but what we've basically gone ahead and done is, we've kind of broken this up into two separate parts. We have a section here that's going to be basically the previewing our web camera and showing what the camera is actually looking at prior to taking the picture. And then on the right-hand side there is where all of our results are going to actually come and show up. So one of the first things that I mentioned is, in this case, we're going to go ahead and use a NuGet package. So if I go into my actual project itself, you'll see that I've gone ahead and added in the Cognitive Services Vision NuGet package. Again, this is basically just simply a wrapper that'll help me go ahead and actually call all the various APIs. It also has all of our types and stuff like that that the service can return predefined for us, as well as the models defined for us, so I don't have to go through and actually implement any of that myself. So once I have that added on there, the next thing that I actually want to go ahead and do is actually look at making sure that my key and endpoint are actually set up properly. So you'll see that that's the key that I actually got from my Azure portal. So that will actually go ahead and authorize my client application to actually make the API calls. And you'll see that my endpoint URL is of a very specific format there. The first part of it being the fact that it's the region that I was created in, not actually what the endpoint in the portal says. If you call it back, so if I were to actually call, or if I were to actually specify what you see here, this IoT demo, it'll actually just return a not found, and it will cause you much, much, much frustration. So just kind of remember that if you're building your own application, that you need to specify the endpoint being the region it was called in versus the actual endpoint that the portal actually shows. So once I have this all set up, I am basically ready to go ahead and create my client. And what you'll notice here is it's just a very, very simple initialization call where I'm basically creating an instance of the client and passing it my API key. Therefore, I'm ready to go ahead and make any of the calls that I want to go ahead and call. The next thing that we're going to actually want to take a look at is what types of attributes do I actually want the API to return for me. And I've only listed a handful here. There's probably about another 7 or 8 different things that I could potentially have the client go ahead and return for me. The things that I care about, accessories, which again are are you wearing glasses, earrings, makeup, stuff like that. Makeup's in there, age, emotion, facial hair, gender, smile. Those are all the types of things that I want to have detected in the picture that I'm actually going to go ahead and send up. And so then, when the data actually comes back, those are the things that I'm actually going to end up binding into my result pane here. And so I'm going to basically go through, parse all the data, and actually show it right here as well. And then last but not least, the other thing that I'm going to have actually come back for me here is a facial, it's called a face rectangle. And this is what the face API actually thinks is coming back. And so what you'll actually see here is we end up simply with the points of a rectangle that it thinks the face is at, and what we need to do is we need to actually scale it based on how big the preview image is actually in our control itself. So if everything comes and works here with a few simple steps, and we should probably get someone else down here instead of me.
I want to do it.
All right, so it's gonna be I'm using the front camera on this for now. I'll go first. I'll be the guinea pig. So, oh, terrible. All right. So you'll see that it went ahead and detected me. It got gender right, male, 1 for 1. Age, it has me about 5 years. So I guess the hard living has been doing me a little bit wrong here, but yeah, lighting. We'll go with that. Blonde hair, good, 97% accuracy. No glasses, no makeup, no eye makeup or lipstick. No beard, no mustache, no sideburns. And then if I look at here, what it does is it goes through. I'm hoping you guys can see this. It's a little tough to see. But it'll actually go through the various emotions here and try to pick. So to determine that I am 0% angry, 0% contempt, 0% disgust, 0% fear, 99% happy, 0.8% neutral. So I guess I took a pretty decent picture here. So Danny, if you want to come up here.
So Rob, why are emotion and smile separate? Smile would factor in emotion.
So smile. All right, you ready?
Psychotic, 80%.
So detect you is 45.
To a man.
Man, killing me here. But it did detect you as 100% happiness. That's cool. But no, to answer your question, I don't 100% know why they separate that out. My only thought is that processing the emotion might be something that actually takes more on the back end. So if you really only care about the smile, then why actually do that? Now, the thing that we're not actually doing here, but you can do, is you can actually get the facial anchor points itself. So if you need to know where your eye corners are, your nose corners, and stuff like that, that is another attribute that when you're actually calling the API, you can set up and actually pull back as well. So if you wanted to mark specific landmarks on your face, you can do that as well. So it's actually pretty cool there.
See if I can break.
You can come on down.
It does have a beard.
So the facial hair detection has been a little bit interesting. You ready? So what you got to do is you got to look and see how close you actually got here. So it's saying with a 92% accuracy, it thinks you're bald.
Go do it.
46 years old.
Oh, way off.
Okay. It's detecting you as a neutral face, and you're 2% sad.
Sad? That's just my face.
So that's kind of just the gist of what I had. If people actually brought laptops and want to play around with it on their own, build it on their own, I'm happy to come talk and help out. If folks want to come up here and just kind of play around with this a little bit, we can fire up the Connect camera as well. I'm happy to do that. But I guess at this point, before the lineup here, does anyone else have any questions about consuming the Face API, scenarios where you might want to use it? Anything else that I might be able to answer for you?
Have you done much with the depth camera?
Yes and no. So some of the stuff that I've done with the depth camera has been more so for object tracking in space. And so I made, not with this, this is with the previous generation, trying to do games with it and try to figure out, how I can relate something in the real world to a game space. So a lot of that's been more with like doing stuff in Unity and stuff like that.
You think you could pretty reliably get the dimensions of a box through the depth?
I think you could if you have proper lighting and the camera at the right angle. So I think that you would want to have those kind of made up. One of the interesting demos that I've actually seen with this is it can actually detect how high somebody's jumping just based on tracking the midpoints on your skeletal system. So it can detect that to pretty close accuracy, so it should be able to detect shapes and forms and stuff like that as well. Cool. Any other questions? So,
What's the minimum requirements on that for a computer?
Depends on what all you're wanting to do, right? If you're just wanting to do like the depth stuff and RGB sensing and stuff like that, it's actually pretty low. And you can actually scale down. Let's say you have an older computer that's just not running as well. You can cut back your frame rate down to 15 frames, 5 frames per second. That will help with some of the massive amounts of data that are coming through. But I've run the depth and camera stuff on a 5-year-old clunker laptop that it seems to keep up with it pretty well.
Single-board computer.
Okay. So I mean, I would say try it. We do have are going to be publishing minimum specs. Where you really start talking about needing the horsepower is with the skeletal tracking. And a lot of that is dealing with, you need like the CUDA drivers from NVIDIA and all that to actually go through and process that and actually look at that. So skeletal tracking, you're going to want to lean more towards the beefy high-end side. But for the depth and RGB stuff, you can get away with a little bit more minimal specifications. Anyone else?
I guess one question is how, like if you were trying to train it for say home automation stuff, right? And you're trying to train an application to recognize people.
Sure.
In a relatively small group, your family, friends, etc. How many pictures, how many different kinds of light, to get the recognition rate to a reasonable level.
So 2 answers for you there. So there's something as part of the facial APIs called people groups. So you can actually create groups of people that you want to be able to recognize. And the original incantation of that supported up to 30,000 people in your group that it would then be able to go through and detect, if a picture that was submitted to it is included in 30,000 people. And they've since determined that that's not large enough. And so I think there's now something called, it's called a large people group. Not so friendly to the size of the people, but the number of people. And I want to say that actually will support up to 1 million people. So you can have 1 million people registered in the people group, and then you can go through and process to see, hey, is this person existing there? In terms of training the model, I mean, it's like with any model, right? The more good data that you put into the model, the better accuracy and results that you're going to have. So if you have, a person, maybe wearing 10 different outfits, or different angles of their head poses, different lighting. Hey, I didn't shower this morning. Let's get a few of those in there. The more samples that you have to train that model, obviously, the better it's going to be able to do ultimately with its confidence level in terms of, hey, is this person that person? So yeah, from an automation perspective, and that's actually we never actually got it. I never brought it to Maker Faire last year, but I actually do have a small little one using like a little like Microsoft LifeCam that will unlock a door if it detects my face. And so, and I never set it up to actually do more than just me. It was just more of a proof of concept. But it was a combination of LifeCam, an electronic door lock, and a Raspberry Pi. The 3 of those together, I'm able to basically walk up to the camera, it detects me, click, unlocks the lock.
Nice.
So. Any other questions? Okay, cool. Well, I hope you found this a little bit interesting. Again, the code is up on my GitHub site if you want to take this around. This could be great for holidays or family reunions if you want to go ahead and play around with, just seeing, how your families and whatnot react to it. It's kind of fun. One of the, it's not done in this sample, but what you can easily do too is Right now, this sample only recognizes one face. You can easily, if you have multiple faces in there, you can kind of switch between them and hover over them and see how each person in the picture reacts. We actually did a game out of this for one of the National League of Cities that was held in Charlotte last year, 2 years ago, where we actually, on one of the big Surface hubs, created a game where you would have two people stand up for it, and we would challenge them to show off one of the emotions. So, give us your best fear face, or give us your best disgust face, right? And basically, we would pit the two people in the picture against each other to see who could show it better, basically. And it was, we had a nice little line of there, people trying to say, hey, what can I do to actually do that? But, to kind of bring it back to the thing you're talking about, home security, you're talking about, other scenarios where you can actually utilize this technology between some of the other devices, being able to do this on the edge, being able, once you detect a face on the edge, to actually do a large group processing and stuff like that to say, hey, where is this person? Have I seen this person before? And combine, what's going on in the cloud, what's going on the edge. I mean, there's a lot of possibilities, and we're only talking one small part of the cognitive services fabric here. I mean, you got, like I said, speech detection, other vision detection, just a lot of really, really, really cool stuff that you can kind of incorporate into your various IoT projects and stuff.
What about the other eye cameras? Are there any other cool ones that you think we should be looking at?
I mean, I think a lot of that stuff, moving to the edge is kind of the new thing, right? When you look at some of the Azure Sphere stuff, when you look at some of what people are designing for edge-based stuff versus what they're designing for cloud-based stuff. I mean, I think you're only going to see more and more of it come as devices. I know Intel, they recently released a device that is kind of similar to that. Doesn't have some of the same time of flight stuff, but I mean, their camera can do some pretty neat stuff too. I mean, so there's a lot of different products out there that are, trying to hit the market a little bit. So it's just a matter of what your ultimate end scenario looks like. Cool.
Awesome.
Anyone else? All right.
Okay.
Cool.
Thank you, Rob. We are going to give away prizes tonight for people.
We haven't had much participation, Dan.
So here's what I suggest. You pick one of these categories, and whoever wants to go for the prize, whoever gets the highest percentage.
I like that.
Who gets the tickets?
Yeah.
And if Thursday night doesn't work for the baseball tickets, I'll give you another night. It's not a big deal.
So if you want baseball tickets, get in line here. Glenn's going to pick one of the emotions, and whoever shows the emotion best wins the tickets.
And if you're looking for a job, please, everyone, come talk to David Kaplan.
Yes.
And
he thinks I'm gonna look 70 on here, so first I gotta see what's up.
Beard, man.
All right, go ahead. Take a picture.
Set.
How old is it?
40.
Look at that, I'm 45.
But it did detect your beard, your mustache, and your sunburn. So you are 100% happy. So
Yes.
I will say happiness is the easiest emotion to hit. So if you're challenging people, I would go for it. Either contempt or disgust.
All right, get in line. Disgust. Who can look disgusted? Let's go.
Yeah, I don't have baseball tickets. I can do that pretty well. I don't want to win with somebody else's tickets.
41.
Oh, 42!
42 on one. Oh, 8.
All right, you're going for disgusted.
I'm going for happy.
All right, go. You do happy first.
And then
Smile.
40.
40! Great.
Now I want to see what
Go for disgust.
That's the smallest thing. We all know what
You're 0% disgusted right now. Is that actually detecting you 65% sad?
30.
You are 0.3% disgust. So we got
current
current leader right here.
How old am I? 33, baby.
I'll go.
Or 4% disgust.
Nice. You're in.
Now you're
Oh, dang. 46% happy. Couldn't figure it out, though.
3 years older than you. All right, Gus.
Yeah, I'm gonna try that.
Came out with 99%
It's like D&D, I'm new to all world.
47?
All right, let's go.
That's funny. Dave was 40. I saw that.
So I got your reading glasses. Are you wearing eye makeup for lipstick? Okay, so it's detecting it. I didn't put the percentages on here, but that means I think 50% or better you're wearing makeup. 55%
Discuss.
You can do whatever you want.
Discuss.
Happy and then discuss.
Okay.
That's younger.
Now are you wearing makeup? Go for discuss. Boom! You got your discuss winner right there.
Yeah, that's an easy one.
I'm younger, so I'm 28 now.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.